Okay, this is Unit 5, Lessons 3 and 4. Lesson 3 is actually an activity. It's not really a lesson. You're choosing the best display. When you display data, you should consider which type of display best represents the data. Example, a city council conducts a survey to decide how to develop a new public park. The council asks people to choose one of 4 park uses, as shown in the table below. Choose and create a display to represent the data from the table. So some of you guys came up with an example. Nathan, you said stem and leaf plot. Stem and leaf plot is one way to represent data, but that's typically only comparing one thing. In this table, we see that we're comparing 4 different activities, and then we have 2 groups, right? So not the best choice. Jayla mentioned earlier a bar graph. A bar graph is a good choice. That's one way, but there's a certain way to go about it. What were some other ways that we can display data? Do you guys remember some of the other ways? Yes?
I did a line graph.
Now, a line graph, again, you're comparing 2 things, actually. One thing on the x-axis with the y-axis. So that's not enough when we're dealing with this many items to compare. Josh, do you have another way? A histogram. Histogram, closely related to a bar graph, but remember a histogram, that's actually comparing the same thing also, just different intervals. Okay? And a histogram is a little different than a bar graph. Remember histogram, the x-axis are intervals, and there's no gaps between your bars. Okay? Does somebody have one other way?
Double bar graph.
Double bar graph. That's the most ideal way. Is that what you use, a double bar graph? There's another way. If you guys remember, we talked about a circle graph, comparing parts of a whole. Okay, that's another way. But let's go ahead and read through what the book gives us as the steps for displaying data. Step 1, summarize the purpose of the display data. Okay, the display must compare data for 2 age groups, 18 and under and over 18. Step number 2. Okay, narrow down your options. There are too many responses to use a line plot, like I said earlier. Each person chooses one use for the park. Since there's no overlap, you can eliminate a Venn diagram. We covered Venn diagrams earlier in the year. You're not showing the distribution for data over a range, so you can eliminate a stem and leaf plot. There's no change over time, so a line graph is not exactly a good option either. And then the last one, step 3, choose one of the remaining displays. Both a circle graph and a double bar graph can compare parts to wholes. In this situation, the table compares 2 sets of data across the same 4 categories. So the best option is the double bar graph. So I want to go ahead and make this double bar graph. Here's our table. Now, for a double bar graph, very similar to a stem and leaf plot. Do you guys remember the stem and leaf plot? They had like a little part that explained the stem and the leaves. What do we call that? Do you guys remember? The key, right? Sometimes you might need something similar to a key. Sometimes I think I've seen it called a legend, a key. If you take a look at here, we have 2 categories that we're comparing. The age group 18 and under and the age group over 18. So for our 2 bars, we need to have something different to represent each group. Okay, we can color code it. We can maybe shade them differently. Since we have the option of different colors, what do you want the color for the bars that represent the group that's 18 and under? What color do you want?
Red.
Let's use a color. Red. I heard red. We'll use red. So we'll make a bar for that group that's red. And then for the other group over 18, what color do you want?
Black.
Green. I heard green. Okay. Now, if we go up to the top, we're going to look at the first group that we chose. We chose red for 18 and under. So here's our y-axis. And the y-axis, the intervals for the y-axis, each line represents how many units? How many? I think that might be a typo. Hold on a second. Let me fix that. I'm missing a unit here, right? What am I missing? So let's make that a fix. And so each line represents 25 votes, or 25 more votes. Okay? Okay, so for my first group, how many of them chose tennis? 72. That's really close to 75, so we're just going to shade a bar just a little bit under 75. Okay? And let's go ahead and do basketball. How many people voted for basketball for 18 under? 114. Now, do we have 114 on the y-axis? No. We skipped, so it's going to be between what two numbers? Between 100 and 25. Now, that interval represents 25 votes, right? So what's half of 25 votes? What's half of 20 votes? 10. Half of 5 votes, 2.5. So 12.5. So 112.5. That's pretty close to 114. So I'm going to roughly shade up to the halfway mark between these two. Okay, and now we have, for the skate park, we have about 173. If we notice, 173 is really, really close to the top of my interval, which is 175. So we can just take a bar and just barely shy of 175. Here we go. Okay, and then the last bar we have to create for this group, gardening. 48. That's really close to what? 50. So just shy of the bar, that's 50. Now let's go ahead and make our bars for over 18. So over 18, how many people wanted tennis courts? 86. That's really close to that's really close. That's between what two intervals? 75 and 100. So now we want to know if we shade a little more than halfway or a little less than halfway. 75 plus 12, because that's half of 25. What's 75 plus 12 and a half? 87 and a half, right? So 87 and a half, that's pretty close to 86. So we'll shade our next bar halfway between, about halfway between. Okay? And then my next bar is 95. And we just did that. So I'm going to say that's a little bit closer to 100 than halfway up to 100. Okay? So that's just a little bit more. And then what about 57? So 57 people wanted a skate park that were over 18. That's between 50 and 75. What was halfway between 50 and 75? 60, 62 and a half, right? So it's going to be a little less than halfway. Or a little more than halfway. Wait, what do we say? Halfway between 50 and 75 is 62 and a half. Right? So we're going to be a little less than halfway. Okay, and then last but not least, what do you notice about this category? What can you conclude about this category for gardening? Old people like to garden, young people don't like to garden. Right? I mean, how many kids are going to say, hey, come on, let's go plant some tomatoes at that park down the street? Are many kids going to say that? No, right? But some old folks might want a community garden, right? Older people. Okay, so 139, that's about, where would we put that between what two intervals? 125 and 150. What's halfway between 125 and 150? Halfway between that's going to be what? 137 and a half. That's pretty close, so we'll shade that about halfway. Okay, so this is basically the introduction to the activity for lesson 3. Not really a lesson. Here's my double bar graph. Remember when we make a double bar graph, you don't have to make the bars right next to each other, okay? But for a histogram, you do. Now, what I would recommend you guys do is on the back of this paper you started this activity on, you're going to answer your 6 questions, okay? And on those 6 questions, I believe they're matching. So what I would recommend you do is write the questions out, write the options out, and if you make a mistake, you don't have to rewrite the answer. You can just draw a line and erase the line. Okay, question? Almost done. I want to show you something. This isn't going to take all period. Okay, I'm going to skip ahead to lesson 4. We'll have some time for you guys to do lesson 3 homework later in this class period. So let's go ahead and skip to lesson 4. Believe it or not, this is actually a warm-up from first semester. What is a box-whisker-plot? If you don't know a box-whisker-plot, skip to step 2. We just did that yesterday. Here. Okay, so a box-whisker-plot. Anybody have a guess about that? Do you guys remember what the box and the whiskers represent? Let's come back to that question once we go over this part right here. This should have been pretty easy for you guys. Remember from the warm-up we did the other day? How do we find the median? And a big thing I want you to remember from first semester, think about the median as cutting the data into halves, okay? Because we're going to try to find and break up the data into quarters, a fourth of the data. Okay, yes? Right. Okay, so she's absolutely correct. We're going to order the set from least to greatest, and then we're going to find the middle number. Is there a middle number here? Is there going to be a middle number? Why not? It's an even set, so there's going to be 2 numbers in the middle. We want 1 number. So if we don't have a middle number, do you guys remember what you do? You take the average of those 2 numbers. Okay? You guys remember that from, was it yesterday we covered that? Yes. Okay. So here's what you need to do. Now there is another name for the median. Second quartile or middle quartile. Okay? If you arrange it least to greatest, you found that these 2 numbers in the middle, you took the average of. Okay? And if you take the average of those 2 numbers, you get 49 and 5/10. Now, that's my first. That median breaks my set into 2 equal parts. Here's my first half of the set, and I'm going to use color coding to help you guys see how we're breaking our set into 2 equal parts. And here's the second half of the set. Now, I need to figure out what the lower quartile, first quartile is by taking the median of the first set. So what I need you guys to do now, take the median of the first half of the set that we created with that middle quartile. So now you need to take another median. It's already arranged from least to greatest. Take the median again. Is the median going to be in the first half of the set? Is there going to be a median in the set of the first half? How many numbers are in the first half of the set? There's 6, so it's even, right? So are we going to have a median in the set? No, we have to make our median by doing the average of the two in the middle, right? Okay. And then similarly for the second half of the set. Okay, so I need you to find the first quartile, and then I need you to take the median of the second half of the set in blue here to find the third quartile. So for the first half of the set, there's no middle number, so we have to make a middle number from these two numbers. For the second half of the set, there is no middle number, so we have to make it from these two numbers, just like we did the median. Okay? Remember, median is also the second quartile or middle quartile. The median of the first half of the set is called the first quartile or lower quartile. And the median of the second half of the set is called the third quartile or upper quartile. If you guys took those medians and calculated them, here's what you get. So here we go. I chose these colors for a reason. In green, the first half of the set, when you find the median, you've found the lower quartile or the first quartile. And look at the box on my box-whisker plot. That's the left side of the box. Do you guys remember that? From first quarter? If you didn't, I'm trying to refresh your memory. If you look, the line in the middle of the box, it doesn't have to be in the middle. It just depends on the data. Okay, remember your question yesterday, like why am I looking at this data and analyzing it the way I am? Because sometimes your values are bunched up and they're about the same value. You see a lot of repetition. Sometimes they're not. And so that's going to determine the shape of your box. Does that make sense? And so if you have like one side of your box, there's a really long whisker, that means you might have an outlier. Okay? Okay, do you remember, are these terms coming back to you? All right. So if you look in blue, that's the second half. And do you see that that's the right side of my box? Okay. What did the whiskers represent? Do you guys remember what the whiskers represent? What does this, the left side of the whisker, the left whisker represent? Do you remember? Can you use some vocabulary words for me? I think I heard it, but I'd prefer you raise your hand instead of calling out. Nathan. No, the first quartile is in green. That's the box. I want to know the whisker, this thing. Who knows what that is? Karis? It's the smallest number, but I want to use the vocabulary words. What's the vocabulary we use for smallest number? Do you remember? Begins with an M. The minimum. Okay? So right here we have our minimum, and our minimum value is 29, right? And then what about the right whisker? What is that value? Do you guys know it now? Because now Karis has helped you out. You should probably know what it is. Henry, what is it?
Maximum.
The maximum. Now, a little review for you. The range, because this ties into what we're going to learn for lesson 4, the range is what? What is the range? How do we calculate the range? Nicholas? Now, use the vocabulary words. We just used them. The maximum. Can I abbreviate that? Maximum minus the minimum. Okay. And what is that going to be? What's the maximum?
73.
It's 73. Very good. And we're going to subtract the minimum, which is what? 29. And what is 73 minus 29? Adipoju? It's going to be 44. Okay? So that is the range. Now, the reason why I'm bringing that up is because we're going to review another range, the interquartile range. And so the interquartile range, quartile range. Okay, or we call that the I, Q, R. And there's a reason why I use these colors. Do you guys want to know why I use these colors? Why did I use these colors? Because we're trying to find the range. That means we're trying to subtract and figure out the width of the box. So the width of the whiskers is from 29 to 72. That's 44 units. So if I was to measure from this whisker on the left to this whisker on the right, it would be 45 units long. Now I need to figure out the range of the box, or the width of the box. So I need to do that. The thinking is the same as the range. I got to subtract some things. What am I going to subtract? Let's use some vocabulary words. Somebody? I can give you colors to help you out. Dominic, can you help us out? What am I subtracting to find the interquartile range? Trinity? You're going to take away the lower quartile from the upper quartile, or given the upper quartile, which is 65, I'm going to subtract the lower quartile, which is what? It was a decimal number, right? 35.5. Okay, and then that will be my IQR. So can you guys tell me what that's going to be? Subtract that for me really quickly. Remember to line up your decimals, and if you don't have a decimal, you can put a decimal somewhere, right? Yes. Who's got it? Unisa, what do you have? Say again? 29 and 5/10. Okay, so this is important for lesson 4. This is part of lesson 4. Okay, I want to do one more example with you. And this is actually a problem from the homework. Okay, this is the standard we're covering. What you'll learn, display data. Data displays can be used to assess the visual overlap of two data sets. You can compare their centers, such as mean or median, and their variability. The way data is spread out, that's what variability is. Okay, informally assess the degree of visual overlap of two numerical data distributions with similar variabilities. Measure the difference between the centers by expressing it as a multiple of a measure of variability. So that's the activity. I'm going to go over an example with you. Okay, so here we have two box-whisker plots. We're going to compare them. Okay, that's two data sets. We have the box-whisker plots. But what I really want you guys to do is I'm going to color code things are the same. What am I color coding on the box in green over here? It's the lower quartile. And it also has another name. What's the other name? First quartile, right? All right, and then in red, what am I highlighting in red, or drawing in red over here? What is this?
The median.
That's the median. And it also has another name. The middle quartile, very good. Okay, and then in blue, I have my other side of my box. What is that called? The upper quartile or the third quartile? Okay, the median has one more name, actually. It can be called the second quartile also. Okay, that's a lot of stuff. But what is the IQR for the first box? What's the IQR? You should be able to mentally calculate that. What is it going to be? I want to know the width of the box. How wide is the box? This one's even easier than the one I did on the last slide. Joshua, go ahead.
3.
It's 3. Look, we can count. 1, 2, 3, or 14 minus 11. What's 14 minus 11? 3. What's the IQR for the other box-whisker-plot? What is it? It's 3 again, right? 20 minus 17, isn't that 3? So the IQR equals 3 again for this other box-whisker-plot. Okay. And then what would the range be for the first? What's the range equal to? What's my range for the Australian Terrier? What is it? What is it? Somebody raise your hand and tell me what the range is. How wide is it from one whisker to the other? Kalila? For that one. Mm-hmm. What'd you, well, those are the two numbers you're going to use, the 9 and the 16. But what is it? No, it's that would be for the range, right? So what is it going to be? How would I use those numbers to find the range? Yeah, let's do it. Trinity, can you help her out? It's going to be 7. So if you take the right whisker and subtract the left whisker, 16 minus 9 is 7. Or if you can count it, 1, 2, 3, 4, 5, 6, 7. It's 7 units long. Okay, so what about the range for the Boston Terrier? What was the range for this? 22 minus 14 and a half. That's going to be 7 and a half. 7.5. Yep, that's 14.5, right? But if we subtract it, it would be 7.5. Is that about right? Yep. Okay. So now I need to get into the activity that ties into your portfolio. So you need to know how to do this for your portfolio. All right, so I answered a couple questions for you for the first half of lesson 4 as homework. Now, this diagram on the right with dog weights in pounds, it's comparing the weights of the pug and the Dachshund, okay? But what does this look like? It's not like any data display we've seen so far, but it looks like it's got pieces of them, parts of some different ones. What does it remind you of? Kayla? What do we call that with the X's? Line plot. So it kind of looks like a line plot. It kind of looks like a stem and leaf plot. But a stem, it looks like it has stems, but there's no leaves, right? But we know with the line plot, the X's mean what? How many times that number repeats, right? So this is kind of like a double line plot that looks like a stem plot. So the book doesn't really explain what this is, but it's like a line plot set up like a double stem and leaf plot. But what's important is that you guys understand how to look at the data display and pull out the data. So what I want you guys to notice, in blue, I'm color coding this again, we're just going to look at this side of the data display. Now, next to the 13 pounds, remember this represents pounds, how many X's do we see? And how many 13s do I have listed over here? 1. And then do we have any 14? No. Do I have a 14 up here at the top in blue? What about 15? No. How many 16s do we have? There's 2. Don't I have 2 16s over here, right here and here? Okay, and then how many 17s do I have? 3, right? So I got 3. 1, 2, 3. And then how many 18? 2, 1, 2. And then 19, how many? 1, 2. So do you guys see where I got the data from the data display? Does that make sense? I'm only looking at this right side, so I'm not doing the whole problem. This is one of your problems, so you might want to have this in your notes to get you started on your homework. Now, we are going to calculate the mean absolute deviation, okay? It's easy. First step is to get your data, okay? So I have all my data. Everybody understands where I got my data from? Okay. Now, how many data values do I have? I have 10 of them. There are 10 values that we have. Okay? Now that's important because what are we calculating next? The mean. How do you calculate the mean of something? How do we the mean and average? That's the same thing. So how do we find the mean or the average? Add them all up and divide by what? How many values do we have? 10. So here I'm adding all the numbers up, and then I get 170, and then I got to divide by 10, and then 170 divided by 10 is 17. Okay, so do you see how I calculate the average or the mean? Okay, so we have the first average we need to take, but now we need to figure out what's the deviation. How do each of the values differ from the average or the mean? And here's how we do that. Now look, they call it the distance. Okay, the bars around each value minus the 17, which is the average, that's the absolute value. That means, does anybody remember what absolute value means? What's it mean? Whatever it is, make it positive. So I take my first value, 13, and I take the difference of that with my average or my mean, 17. The difference of 13 and 17, well, that's going to be -4, but the absolute values turns it into a +4. You understand? So all of these differences are going to be a positive number, even if you take the difference as negative, because the absolute value makes it a positive. So I did the same thing for 16. 16, the difference of 16 and 17 is -1, but the absolute value makes it a +1. I did that again for the second value of 16, +1. For 17, I did that again. 17 minus 17 is 0, but the absolute value is 0, 0. So I repeated that. 18 minus 17, well, that's going to be a +1, and the absolute value of +1 is +1. Similarly, for 19 and 17, that's a +2. Absolute value of +2 is 2. Now I have a new set of data. This is all the differences between the value and the average. And here I list all those differences. Do you see that? This is my new data set. It's the data set of the differences that the values deviated from the average, how much they differ from the average. That's what this is right here. Got it? It's a list of numbers. Okay, now what you need to do, this is how you calculate the mean absolute deviation. You're going to take the mean of this set of data, and you have your answer. So if you take a look, I take the sum of all these numbers that I came up, and I'm going to divide by what? 10, because there's 10 of them, right? So it's 12. It ends up being 12. 12 divided by 10 is 1 2/10. That is the mean absolute deviation. You will see that on a quiz. You will see that on a unit test.